Okay, welcome to this math class. The math class is brought to you by Vision Concepts. We're going to be tailoring our series of videos to people who are writing WAEC, GCE, JAM, and any other related exams that you'll be doing in this category. We'll start with the first topic, numbers, basic operation, and numeration. Numbers, basic operation, and numeration. Numbers, as we know, are mathematical symbols for counting. We have different kinds of numbers. We have whole numbers, like your 0, 1, 2, 3, and so on. We all know them as our decimals, our decimals to base 10. We have fraction. Fraction is part of a whole. So it is denoted like this, A over B, where A is the numerator and B is the denominator. Examples include like 1 over 2, like 3 over 4, like 7 over 8. We'll talk about fractions when we come to that part. Then you have negative numbers. Both whole numbers and that's whole numbers positive and negative numbers are known as integers. So negative numbers. So example includes -3, -4, -5, etc. etc. It's endless. It's endless. So you have decimal. Decimals are written in forms that has a point in between numbers like 0.1, 0.02, 3.45. This is decimals. Like I said, integers is numbers that are positive and negative. So most of the times we see them on the number line. You see -2, -1, -0, sorry, not -0, 0, 1, 2, 3, and so on. So these are numbers. These are numbers. Now for basic operations. Basic operations are just mathematical symbols that are used to compute numbers. Mathematical symbols that are used to compute numbers. Basic operations in mathematics are, example, plus, minus, multiplication, division. I know we know all these things at this level, but it's just to bring our minds to how these terms are being used. So these are basic operations. So we know addition, subtraction, division, and addition, subtraction, multiplication, and division. So there are laws of basic operations, mathematical operations. We have these laws. The first one is commutativity. What does that mean? If, for instance, you have A plus B, it is the same thing as saying B plus A. So look at this expression, they are the same thing. A plus B is the same thing as B plus A. That is, even if you invert the positions where A and B is. If I change the position, if second thought I say I want to add B to A, it is the same thing as A plus B. So this is commutativity. It means that plus addition is commutative. Also, multiplication, A times B, is the same thing as B times A. No matter the position where your terms are, these are called terms. These are called terms. A is a term, B is a term. B is a term, A is a term. No matter the position where the terms are over the operation plus, operation division, multiplication. No matter the position of the integer, yes, that operation will stand. Example, if I say 5 plus 3, we know it's the same thing as 3 plus 5. If I change the position, it's the same thing. It's the same thing. And if I say 2 times 4. It's the same thing as saying 4 times 2. So this is commutativity. So it means that addition is commutative. Addition is commutative. Also, associativity is the next law for mathematical operations. Associativity. Associativity. What does that mean? What does that mean? If I have A times, if I have A plus B plus C, is the same thing as saying, that is, if I put a bracket here, for instance, it's the same thing as saying A plus B plus C, I put a bracket here. So it means that I can associate, if I have like more than 3 terms and above, I can associate the terms, maybe the first 2 terms, and do the operation on it, and carry on to finish up the operation, or associate the last 2 terms, that's by bracket. Understand? So example for this part of this law. If I have 5 plus 2 plus 1, even if I come here and associate these 2 together and work on this before I work on the result, work on the third term. 5 plus 2 is 7 plus this one, which is 8. If I come here, the same expression, and I associate the last 2 terms like this, and I do the last 2 terms first. 2 plus 3, 2 plus 1 is 3, plus this 5 here, it will still give me 8. So it means that addition is associative. That is, the mathematical operation addition obeys the law of associativity, and also multiplication obeys the law of associativity. I'm going to take this one off so that we can continue the laws. Okay, so I'm going to give an example of multiplication. If I have A times B times C is equals to A times B times C. If I associate these 2 like this, and associate the last 2, it means that A times B times C is the same thing as, if I work on A times B first before I now take the result and work with C, it's the same thing as working with the last 2 and multiply by the first term. So it means that multiplication and addition are associative. Multiplication and addition are associative. But what about addition and subtraction? They are not associative. I will put a rule generally for all of them before we finish. The last one is distributive or distributivity. Distributivity. For distributivity, if I have this expression, A plus, that's into B plus C, for instance, okay, is the same thing as saying B plus C into A. Okay, look at it this way. Distributivity means that if I have an operation that is in between, before the brackets. So if the operation is multiplication, mind you, there is a multiplication operation here. We don't write it for the brackets. It's an operation there. So if you have A into B plus C, now distributivity means that A will multiply B to get a new term, or the first term, and A will multiply C to get another term. So this is how it goes down. A times B is AB. This is now the first term. Plus this same A again times C is AC. This is distribution. A is distributing into this bracket. So it's the same thing, distribution. Again, A times B is AB, that's from this position. A times C is AC, the same thing. It will give you the same result. So that is distributivity. So what is distributing? And multiplication is distributing. It means that multiplication is distributive from left to right and right to left. Multiplication is distributive from left to right, that's from left to right or right to left. So multiplication is distributive. And what else again is distributive? Division is distributive as well, but only from left to right. Let me explain. If I have this B plus C divided by A, for distribution here shows that I can say B over A plus C over A. So this division has distributed what into this bracket. So distribution is, division is distributive from left to right only, but not from right to left. I cannot do it either way. I cannot come here, for instance, and say A divided by B plus C. I cannot come here and say A over B plus A over C. No, it will not work. It will not work. It will not work. So division is only distributive from left to right and not from right to left. From right to left and not from left to right. So let's go over all the basic laws of operation, the basic operation laws. We talk about commutativity, saying that if you twist the terms, if you change the position of the terms over the operation plus and multiplication, you understand, it doesn't change anything. So plus and addition and multiplication is commutative, but subtraction and division is not commutative. So that is for this one. So only addition and multiplication is commutative. Subtraction and division not commutative. Then for associativity, addition and multiplication again is associative. So division and subtraction is not associative. And finally, for distribution, now distribution now is from left to right, both operation. We see that addition operation is distributive. Subtraction operation is also distributive, but division is distributive only from the left to the right and not from the right to the left. So these are the laws of the basic operations in mathematics. So we'll move ahead to numeration. Numeration is like number systems. So I'll claim we talk about numbers, we define numbers, we look at basic operation, this is what we have done now, and we're coming to numeration. So numeration is number systems, system of numbers, from what you are already used to, what you interact with in your letters, in your subjects that you do, other courses that you do. You see that all the figures you put down, calculations you put down, they are all in denary, that is in decimals, in base 10. So number of systems are, that's numerations and number systems. So number systems include denary or decimal. You can call it decimal, and it's in base 10. And that's the one that we know. So examples from 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It stops at 9. The next term will now be a combination of whatever we have here. So this is the first number system that we know. The next one is binary. Binary is another number system that we know. You have is known as base 2. This binary is base 2. It's either a 0 or a 1. This is mostly found in computational systems, in algorithms, in computing and programming. So 0 and 1, just 0 and 1. It must not, if you see any number that has more than this, it's no longer a base 2. Okay, so the third one that is common is the octal. The octal system, number system, is in base 8. So in it, I have 0, 1, 2, 3, 4, 5, 6, and 7. It stops at 7. So any time you see a combination of numbers that does not exceed this range consistently throughout, it's an octal system. Octal system that is in base 8. And the next one that is common is the duodecimal. The duodecimal system. Duodecimal is number system in base 12. So I'm going to give you examples. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So who can guess the next one? It's not 10. It's X. And you have A. So this is the duodecimal. And the last common one is hexadecimal. So for the hexadecimal is base 12. Base 16, sorry. Base 16. So example is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, not 10. 9. After 9, you have A, B, C, D, E, and F. These are numbers in base 16, known as hexadecimal. So, in the next video, we are going to be looking at calculations, how to change base, because we are used to this number system generally. So we need, sometimes you can change base from, change base from base 2 to base 10, or base 10 to base, any other base that we have here. So thank you for watching. I hope it's informative for you, and I'd like to thank you for viewing.